Hello, in this video we're going to be illustrating the incidence postulates in Euclidean geometry via the program GeoGebra. And this free program GeoGebra will be used extensively for a lot of my courses actually, but especially for my college geometry course, in which my students will become experts at using this program before they get to the end of the course. And this is an extremely robust program designed to create dynamic geometric constructions and connect them to algebraic representations. In the program, you can turn on an algebra window, a spreadsheet window, and two geometry windows, and actually a CAS window as well, in any combination, all interacting with each other. And we'll start by just showing a single geometry window. Within that, the native view and tools provide an interactive dynamic environment for viewing Euclidean geometry, and there's a robust set of tools that allow us to perform geometric constructions. Be sure to click on the link above to watch this video. Well, that's for my students who are reading the notes. The video will go over visualizations of basic incidence postulates in Euclidean geometry. So when we're getting started, you want to first log on to www.geogebra.org, create an account, for my students preferably at this point using your school email address, and then go to app downloads and under offline apps and pull down the latest version as I'm writing this or making this video is version 6. Pull that down and install it on your computer or tablet so you can use it even if an internet connection is unavailable. You might also want to install the Geometry, Graphing Calculator, and 3D Calculator apps as well. There's a web version of the software that should work even on smartphones, so technically you don't even have to download it, but it's kind of useful to have on your computer as well. You might want to go to the App Store for your phone's operating system and download GeoGebra apps there. There's also an augmented reality app that's pretty cool. So there's lots of different things we can do there. So let's take a look at that part just real quickly. So here's a browser, and I've already gone to GeoGebra.org. Okay, and here is on this side over here, you'll see a menu and so forth. Up at the top, let me see if I can, let me make this where you can actually see the whole window a little bit better. Okay, so up at the top right here, you will see a thing that says log in. You can click on that, go to that to create an account or to log in, I've already logged in, so it's showing my picture there. You can click on this button here and open the different apps right here. So for example, we can open a geometry app right here. There's a 3D calculator, graphing calculator, the calculator suite, which has some different options on there. The scientific calculator, notes, and then the classic. If we just go to the classic version here, then we can, again, within there, we can pick what we want. I'm just going to go to the geometry version, actually, which I could have just gone to the geometry to begin with. So this is the basic geometry setup. So this is the simplest one in some ways. So here we just have a blank screen. Now this represents a Euclidean plane, at least in its native way of thinking of it. And you have several different tools given on this toolbar, and almost all of these are some kind, well, all of them are, some kind of drop-down menu that collects a number of different tools there. And I don't know if I'll go over all of these in this video, but let's go over a few of them. The first one is the upper left hand where we have the move tool. You're going to select that a lot of times to grab things and move them around. Now, geometry is about points, so we can start by just selecting here and we can make a point. These are free points. I get the move tool and I can move these points around. These are free to go anywhere we want. And there are actually infinitely many points in this plane, so we can make as many of these points as we want. Now, there are certain things here under the line collection here. There's a line. Given any 2 points, there is exactly one line containing them. So if we click on those 2 points, that creates that line. Once again, if I do move, this moves the line. If I move the points around, this is dynamic. So the whole cool thing about GeoGebra is how it's a dynamic software. And so this shows you that no matter what 2 points we pick, there is exactly one line containing those 2 points. We can also make a line segment. A line segment we'll talk more about next week, but a line segment is a portion of a line, okay, that consists of the 2 endpoints, in this case the points C and D, and all the points between them, which is given right here. And you can see this illustrated in Euclidean geometry. So there's a dynamic line segment. We can also have array. Again, we'll talk more about this next week. But array is also defined by two points. It has one of the points, which is an endpoint, and it's a half of a line. It goes on forever in one direction, but not the other. It's completely controlled by these 2 points. Now, if I go to point, when I create a point, let me show you some differences with a couple of things. Notice if I look at point G, it looks like maybe at the moment that might be on, maybe that's actually on line AB, or it might be at the moment, but it's not constructed that way. So if I move G, or if I move A or B, it may no longer be on AB. So G is not a point on line AB. It is a point that's actually a free point. But I can make a point be fixed to line AB. One way I can do is point on the object and then click on the object. Now, if I try to move point H, I can move it along line A, this line A containing A and B, but I cannot move it off of there. So this point's dependent on that line. It's actually a point on that line. We can take a point here and attach it to that line. So now the point was not on the line necessarily, but now it is. I can also detach it. And so now that it's back a free point again. One of the things is that we like to do a lot of times is look at where lines intersect. And so let's make another line here. And we might look at the lines where they intersect. We can select the 2 objects, and it will create any points where they intersect, that point K. So notice that 2 lines, when they intersect in at most 1 point. There's somewhere I could put this where we do get parallel lines that don't intersect, so that is a possibility. Or of course I could set it at least temporarily where the 2 lines are really the same line, so there's infinitely many points in common. But if they're intersecting 2 distinct intersecting lines, they intersect in exactly 1 point. Okay, so let's take a look back at our list of postulates from here. Here are some of them here. So collection of all points is a set. So in this case, we're dealing with just a single plane, but there are points in that plane. Lines and planes are geometric figures, so they're sets of points. So we want to have that way of thinking about it. There exists at least 4 non-collinear, non-coplanar points. We're not talking about the non-coplanar at this point because we're within a single plane, but definitely there are points that are not all on the same line, and we saw that here. For example, the point G is not on this line that contains A and B, line AB. Okay, let's see. And again, we'll talk about planes a little bit later, but postulate 7 is somewhat illustrated here because it turns out that if you have this line and this point, say this line AB, and this point G that's not on the line, the only plane containing all of that, these 2 points and these 3 points, is the plane that we're illustrating here in GeoGebra. If 2 points lie in a plane, the line containing them lies in that plane. Okay, so we can see that. Given the fact that that we have these 2 points A and B in this plane, that entire line stays in that plane no matter where I put it. So that's kind of an illustration there. And let's see. 2 distinct planes intersect, their intersection is aligned. Right at the moment, I'm not doing a 3D version here. I'm dealing with a single plane, so that will come up a little bit later. Then our propositions, certainly at least 6 lines and 4 planes. Again, I'm only illustrating one plane at the moment, but we can have definitely different lines, which I think you can see that pretty easily. 2 distinct lines intersect. They intersect exactly 1 point. We just talked about that. And this one deals with a plane and a line not on the plane, so we'll talk about that later. And then proposition 4 is kind of like what we just said, that if this line and this point are the points not on the line, there's only one plane containing that line and that point, and that's the one that we have that we're working within. Okay, so we can kind of see these incidence properties kind of play out here, and we can also look at some other types of objects and some other things that we can do. So let's also talk real briefly about some basic things that you can do in GeoGebra. So let's look at some other things that you can do with the tools. One thing we can do is find the midpoint or center. So if we have 2 points, you can click on them and they'll find the point that's in the midpoint. So the distance from D to L and the distance from L to C is the same, and it's actually between them, so it's on that line. And this is going to remain true even when I manipulate it. So notice that I really can't do anything about moving L because it's completely dependent on where C and D are. Let's see. I think if I have, let's check this out. Let's make a line segment. I can actually also do this one if I just click on the line segment, it also finds the midpoint there. So that makes sense for us. Let's not worry about these other things just yet. Okay, so let's leave those alone. Okay. One important thing in Euclidean geometry is the parallel postulate. So let me do this. Let me right-click, and then I can highlight, and then hit delete, and I can delete several things here. Oh, before I do that, let me just show you something. If I delete point E, that ray goes away because it depended on point E. Okay, let me show you something else. If I want to make sure that a line these lines intersect, well, let me show you this. If I take another line, just make another line, that line may or may not, these are intersect the other one. It's a 2 general lines, so there's somewhere I can put it in here, if I could get it just right, where it would be parallel, and other places it would intersect. And even if I have it generate the intersection, that intersection is only going to be there if the 2 lines actually intersect. So somewhere in here, they're parallel, and that point E was undefined. What if I want to force the lines to intersect? So let's get rid of D. So I want it to go through C, but I want it to intersect, say, say at A. Well, I can just create my line going through C and through a point on here. Now, these lines cannot be made parallel because A has to be a point in common to the two. So no matter what I can do to C, I can't make them parallel. I can make them the same line temporarily, but I can't make them parallel lines. All right, so here we have a point not on the line. This, okay, or at least temporarily, at least it's not on the line. And the Euclidean parallel postulate says that given a line and a point not on the line, there exists exactly one line through that point parallel to this. Of course, it's parallel, so it's in the same plane. That's part of the definition of parallel. And since that's something that we can do, only one such thing exists, there's a tool for that, parallel line. So here I can click on the point and the line, and now it's parallel. If I move A and B, it stays through point G, but they stay parallel. I can move point G, again, it stays parallel to that line up above. So these two lines will not intersect. And there's exactly one such line. That's a property of Euclidean geometry. Okay, so let's just make another free point. Okay, another thing we can do is perpendicular lines. So if I click on a point and the line, then this is a right angle so that all four of those angles formed there are the same size. 90 degrees or pi over 2 radians would be the measure of that angle. I can do this with a point that's a free point, which might be not on a line. I can also do it with a point on the line. We'll see later on that given a point on a line, there's exactly one line perpendicular to the given line through that point. And then a later theorem says given a point not on the line, there's exactly one line parallel to the given perpendicular to the given line through that point. So these are perpendicular lines through a point on the line and through a point not on the line. Theoretically, there's quite a bit of difference in those two ideas, but they still boil down to the same thing in the sense that we've got some perpendicular lines. All right, we can make angles by making two rays. There's a ray, and another ray with a common endpoint is what we call an angle. And so we can look at an angle here. If we have an angle, we can create its bisector. Actually, in my class, this would not actually be an angle bisector because an angle bisector would be a ray going from here out this way. This also includes the opposite ray as well. I'm not going to include that as an angle bisector in my way of doing things. Okay, let's see here. We can also do some measuring things. So one of the things that we can have is if we have 2 points, we might measure the distance between them. And that's under this one right here. This is your measurement stuff. And so we can click on the 2 points, and it tells us that distance from A to C is 7.54. Once again, it is dynamic, so that we have this here. And this, there is a underlying grid that we could put on here, and then this would be consistent with the underlying graphing grid and consistent with the Euclidean distance formula. We can do the same thing for a line segment. We can say, we can click on the segment, I think, and it will give us the distance there. And the label just kind of follows the line segment around and measures the length of it. So that's the length of the line segment, or the distance between the 2 points. If we have an angle, let's go back to making an angle again. We can measure an angle this way by clicking on 3 points. It puts a little marker there, and it labeled that angle alpha. Notice I keep going back to the move tool to move things around, and that will measure that angle. Right now it's measuring that angle in degrees, and it is measuring it from this one counterclockwise to that one there. There's a way to change that. We'll talk about that later, where it always measures the shortest rotational angle, or you can measure in radians. So there's a couple different options that we can get to later. So you can create an angle with a given size, and we can say, okay, say 45 degrees, depending on which direction you want to go, clockwise or counterclockwise. And that gives 3 points. Now to actually make the angle, we'll need to make some rays going here and here. So what that really did was rotate that about the H about the point I 45 degrees that direction. And so notice this one is such that no matter where we put this, it stays 45 degrees. Okay, let's look at some circle things that we can do. A circle through a center and a point. A center and another point determines a circle. A circle is a set of all points which are equidistant from this given point. So if I do the, doesn't matter where I put a point on that circle, and I can do point on object, but you can actually just select the point thing. If you click pretty close to the object, it's going to snap to it. So that's actually created on there. I can't pull it off. And if we measure the distance from L to J, J being the center, that's going to stay the same no matter where we go around it. Now by changing K, I can make it bigger or smaller distance. But that will make sure that those are the same. For example, it'll make sure I can put line segments here and here. We call these radial line segments. Those are going to be the same distance, same length. Okay. You can also create circles by center and radius. Like we can put it here and say we want it to have a radius of 2. So notice there's no control point on this one on the circle because it's always going to stay a radius of 2 no matter where we put it. And there's various other options here for things that you can do there. It has some conic sections here, different things you can measure, different transformations that you can do. And you can do polygons here. Click 1, 2, 3, and if we click back on the original, that makes a 3-sided polygon and shades its interior. Technically, the polygon is just the 3 line segments, in this case a triangle, and this is not really the triangle, it's what's called the interior of the triangle. But when you use this tool, it grasps both. And again, you can make it as many sides as you want. Just click on whichever many points you want. Just be sure you click on the starting one at the end. And now we have a 1, 2, 3, 4, 5. That's a pentagon. Actually, you can make it degenerate where it's not a pentagon, like that. But there we go. And all of these things we're going to talk about in more detail as we go on a little bit more. And there's a few other things that we can build here. We can build some sliders, text boxes, and so forth. And there's lots of different things that we can do as we get a little further on into this. We can explore some of these options. But for right now, I just wanted to kind of give you a very brief overview of some of the things that GeoGebra has in it. So here's what I would suggest that you do at this point. First of all, get on GeoGebra, get yourself an account if you haven't done that already. Download the classic apps. You can work that on your computer. And oh, let me show. I guess I should show you where that is. So if you go to back to GeoGebra, to the website, let's just go to geogebra.org. Okay. If you go to here, you can download certain things, but if you go to app downloads right here, then these are some of the apps that you can download. So for example, I would at least download GeoGebra Classic 6 and install that on your computer. Now, the other cool thing about GeoGebra is that this is sort of a community that has used this to make different these GeoGebra activities, they're called, using these apps to make several different GeoGebra activities for exploring different kinds of mathematics. And the cool thing about it, the software is free, but also the people are pretty free with sharing their things that they've created. So if you look here, there's different classroom resources that you can look at. You can use this little thing here to go to different areas like geometry. And within geometry, say you might be interested in, I don't know, let's say you might be interested in congruence. And here's some suggested activities that you can look at for congruence. You can also type in something right here and just search for a certain thing. So for example, I might search for triangles. And then there's going to be certain things about apps about triangles. Now these vary in quality. Some of them are extremely good. Some of them are not quite as good. But there are a lot of them that are very, very cool that people have made. You can also build your own resources. I've built some. These are my resources, some that I built, or there's a few of them that I've copied, but mostly I built. You can also make you a structure here to save them, folders and so forth. And so there's different things that we have here, and we'll look at that a little bit later as we go through the thing. When you have a GeoGebra, maybe we should go back to here real fast. And let's go to geometry again. Now this version of geometry has the tools, some of the tools over here. So it's a little bit different than the classic app as far as that goes. But let's just say I make a circle like this, and then maybe I make a line segment. Okay, so there we go. You can click on more and see lots of different tools. So you're going to get all the tools that you got before. They're just organized a little differently. But one thing I can do is I can save this. So if I go over here to let's see, I can share. Change a lot of settings there. Let me go to, let me see if I can go back to the classic app. So if I'm going to the classic app on my computer, here, let's just say I go to geometry. If I build something, whatever, something simple like a quadrilateral, then I can take this and click on this little thing right here, and I can save it. I can give it a name, and I have different options. I can make it private or shared. If it's private, then no one can see it but myself. When I'm ready later on, I can change that, but I can go to shared, and then nobody's really going to see it unless I share the link with them. But it is saved on the GeoGebra's site, and so that is that's pretty cool. So we can save things. In my class, you'll be saving these things and sharing the links with me. You can also do a screenshot by just doing print screen, and then saving that, but you can also go here and do export image. And so we can copy that to the clipboard and then paste it in a Word document. So that's going to be how we're going to save a static image and put it in our case, a Microsoft Word document. But we also want to put a link in the document so we can get to the dynamic version of it. Okay, so that's just a quick overview. I'm not going to save this one in this case. Okay, but then here are some tutorials, and I suggest you maybe go to these. This one here has some different ones, like if we go to this one here, this Geometry 1, you can go through here and it tells you to do certain things, and it just gets you through these. And as you do these things here, move A into the square. Of course, it's only temporarily there, but it's just seeing if you can follow some directions. It's just right now just seeing if you can select points and move them. If you get it, good. Now it's telling you to do some other things here, and just follow the directions. It will click off these, check these things off as you go. But it gives you a really quick, basic introduction to some of the basic tools. Doesn't take you very long at all to work through these little courses, and I think it does a pretty good job of that. So you might try that. The GeoGebra team has put together some different introductory tutorials. Here's a link to that. This guy here, Jonas Hall's, put together a handbook of some more advanced things that you can do, and there's a GeoGebra manual. So there's a few different resources you can look at. Let's stop there, and we'll go on to look at some finite geometries in our next video.